Hello everyone, welcome back. Today we are going to be looking at quadratics. We're going to do two exercises, 4a and 4b, which is pretty much just going to be reviewing all of the concepts about quadratics that you've learned previously. So to start off with 4a, we are reviewing quadratic functions, and what you need to be able to do is find the x-intercepts of a quadratic equation, put the equation into turning point form, and sketch a parabola including transformations. So what is the information that you need to know about quadratics? Well, first of all, you need to know the general expression. It's got a power of 2, that's just going to be its leading power, and its general form is y equals ax squared plus bx plus c. The shape of it, the function has a minimum value if this a value is positive. So what we mean by that is the shape is going to have a smiley face essentially, and it's going to reach a minimum value. The y value is going to be the lowest. If a is negative though, it's going to look like this. So it's going to have a maximum value there. So that's the shape. Quickly draw that up for you. So that's if it's a minimum, and that's a maximum. All right. To be able to sketch a quadratic function, there are 3 key points that you always need to find. So you need to firstly calculate the y-intercept. So that means when x is equal to 0. You need to calculate the x-intercepts. So that's when y is equal to 0. And you need to find the turning point, which is generally our h and k. And the next slide will show you how to find that turning point. So to find the turning point, there are 3 ways to do it. I'm going to zoom in because they are tiny. So first thing you can do is to complete the square. It really depends on what type of equation that you have. If it's something that is monic, so usually if you don't have an a in the front, if it doesn't involve many fractions, I would go for completing the square. If it has really yucky numbers, you might want to just plug it straight into this formula here. So you can just plug in the numbers and you can find your x and y value of the turning point. And the other thing you can do is average your 2 x-intercepts, and then once you've done that, you can substitute them back into your original equation to find the y value. You should be confident with all 3 because, again, it just depends on the type of equation that you have that you will use, whichever formula it is. In order to calculate the x-intercepts, there are 3 ways to also do that. The first thing is that you can factorize your equation. This only works sometimes, depending on whether the 2 numbers work out, where you need to multiply 2 numbers to get your c and add to get your b value. You can also complete the square and then solve it from there. And then finally, you can use your quadratic formula. Again, if you have pretty yucky numbers, I would just go straight to the quadratic formula. Finally, your quadratic itself, as we kind of talked about before, looks like this. So this is what we call a parabola. This is where a is positive, and that's essentially the shape that you need to know. So this is the main information that you need to know about your quadratics, and now we're just going to go through a few examples to demonstrate all of this. So example 6 says, use an appropriate technique to factorize each of the following quadratic expressions. So at first sight, this might not look very obvious because usually what we say is 2 numbers that multiply to give us this, add to give us this. So it's not really that helpful for this one. But there are a few kind of formulas that you need to know. So your difference of 2 squares and your difference of perfect squares. So the first thing I can notice is that this here and this here, both of them are perfect squares. So what I mean by that is I can write 9a squared as 3a all squared, and I can write 16b squared as 4b all squared. Now, what I'm trying to think about is the formula a squared minus 2ab plus b squared, which equals a minus b all squared. So if that's the case, and I know there's so many a's and b's here, so it's kind of confusing, but this is my first variable, this is my second variable, and if I were to do minus 2ab to these two, if it equals this, then it fits perfectly into that form. So let's give that a shot. We're going to go 2 times 3a times 4b. 2 times 3 is 6 times 4 is 24ab. And it's a negative, which is where we get this negative in the bracket there. So that works, okay? So this one's a little bit of a tricky one because you have to try and recognize this particular form here. But as soon as I see a perfect square with the first number and the last, first term and last term, I'm thinking about that form, the a squared minus 2ab plus b squared, or of course, if you have a plus, you can have a plus there as well. All right, so now that we know that, essentially, and again, this is kind of confusing, but my a term is 3a squared and my b term is 4b. So I can substitute that straight into the formula. I'll get 3a minus 4b squared. So this question is just purely recognition, and it takes a little bit of practice to get there. All right, that's part A. Now, part B says we need to factorize this. Usually what we do are 2 numbers that multiply to give us the last, add to give us the middle, but because it is a non-monic polynomial, which means we have a number in the front, we actually need to multiply these 2. So the 2 numbers that I'm looking for, so a times c, needs to equal 6 times 7. So 6 times 7 is 42. I want two numbers that multiply to give us 42 and add to give us negative 17. So you kind of have to think about what those two numbers might be. They will be, in fact, negative 14 and negative 3. So the first thing I know is that both of these need to be negative because that's the only way to get a negative in the middle, but a plus at the end, because two negatives multiply to give me a positive. All right, because it's non-monic, what we now need to do is separate that middle term. So I'm just going to bring the 6x squared down. Negative 17x can separate into negative 14 and negative 3. So it's up to you whichever way you want to write it. I just try to pair up what matches nicely. So 6 and 3 matches, 14 and 7 matches. So that's why I did it that particular way. But it doesn't matter if you did it the other way as well. All right, we're now going to factorize. Now, one thing I did miss is the x's. So all I've done is I've rewritten negative 17x as negative 3x minus 14x. And I'm going to factorize by grouping now. So what can I see in common here? There's a 3x. So I'm going to take that out. I'm going to be left with a 2x minus 1. And then what can I see in common over here? I can see that there is I'll probably want to take out a negative number so that I can end up with a negative there. So negative 7, if I took out the negative, then it leaves behind a positive 2x plus 1. Now these two are common, so I'm going to factorize that. I'll end up with 2x minus 1, and then what do I have left over? It's a 3x minus 7. Okay, so a little bit of a tricky one. There's quite a few steps to it, but if we kind of just go over what were the different steps that we completed, the first thing that we did was this a times c thing, because there's an a in the front, and I worked out my two numbers that I'm going to split up into. So the second thing I did was I went ahead and split the middle term. The third thing that I did was I factorized by grouping, and then the last thing that I did was I factorized out the common term. So if you split it up into these steps, hopefully it'll be quite straightforward to follow. Now, the null factor law says that if I have two numbers that are multiplying by each other and they're going to equal 0, well, the only way for me to actually get that 0 is that one of these have to be 0. That's the only way to be able to multiply something to get 0. So that means either A needs to equal to 0 or B needs to equal to 0, or both need to. And that's exactly the concept with when we factorize. When we factorize something, we end up with two brackets. So it's like two numbers being multiplied. So either this bracket needs to equal 0 or that bracket needs to equal 0. And that's how we go ahead and solve. So when we look at example 7, it says solve this particular equation. We're going to do something very similar to what we did before because it's a non-monic polynomial. So we're going to multiply these two here. So we'll end up with, we need two numbers that multiply to give us negative 18 and add to give us negative 7. When we think about those two numbers, they're going to be negative 9 and 2. Negative 9 and plus 2. So that's what's going to give those. So I'm going to go ahead and split that middle term. So that'll be 6x squared minus 9x plus 2x minus 3 equals 0. And now we're going to go ahead and factorize by grouping. So we're going to look at these two here. What's common? We can take out a 3x. There'll be 2x minus 3 left over. Here I can't take out anything, so I'm just going to write plus 1. And now we can factorize these two out because they look exactly the same. That's 2x minus 3. And what's left over is a 3x plus 1 is equal to 0. Okay, so now we're up to the point where we have to either look at this bracket needs to equal 0 or this bracket needs to equal 0. One of them has to be 0 or both in order to give us an answer of 0. So if we go ahead to solve this, take the 3 over, divide by 2, and then I'll take the 1 over and divide by 3. So those are my two possible solutions for this quadratic here. Okay, another way that we can solve a quadratic is through the quadratic formula. So the quadratic formula is used, really, you can chuck in any formula, any equation into here. You've got your A, B, C, but I tend to use it when the numbers are really gross and I can't seem to solve it. This one, I mean, the numbers don't look that bad, but if you do want to, if you want to try and factorize it, two numbers that multiply to give you 3 and add to give you 8, well, it's not really possible. So here I would either complete the square or, of course, we can use the quadratic formula. So one concept of the quadratic formula is the discriminant, and the discriminant actually tells me how many solutions I have. Now you'll notice that the discriminant is actually this part inside the bracket here. What's the purpose of this? Well, essentially what it's trying to tell us is depending on what this number is inside the bracket, I'm going to have a certain number of solutions. So for example, if this part inside the bracket, the discriminant, is positive, well then I'm going to have two real solutions. And I know that because when I take the square root of a positive number, I get plus minus a certain number. So if I have the square root of 4, I get plus minus 2. Now, if it is 0 though, well the square root of 0 is just 0. There's only one solution. There's no such thing as a plus minus. And finally, if it's the square root of a negative number, well, we know that you can't take the square root of a negative number. So it's undefined, which is why we end up with no solution. So you really need to connect this term, the discriminant, to two solutions, one solution, and no solution. It's really important that those are associated with each other. All right, so example 8, we need to solve this equation. We don't need to find the discriminant, but just because it's there, I'm going to go ahead and find it anyway, just so that we have a bit of practice. First thing I'm going to do is go ahead and label my A, B, and C so I know what to substitute in. In order to find the discriminant, I'm just going to quickly write out the formula. That's B squared minus 4AC. So that's going to be 8 squared minus 4 times 1 times 3. So that'll be 64 minus 12, which is 52. So because this is a positive solution, then I know I'm going to end up with two solutions in the end. Okay, now what I can go ahead and do is substitute everything into my quadratic formula to be able to solve it. So it's going to be negative b plus minus b squared minus 4ac. I actually just worked it out, so I can just plug that number in straight away, but that's fine, over 2 times a. All right, and now it's just a matter of solving this. So negative 8, I worked out before that the number inside the square root is 52. 2. And then we're going to try and simplify this if we can. So the first thing I can recognize is that root 52 can be written as 2 root 13. The reason for that is that 52 is the same as 4 times 13, and when I pull the 2 out, when I pull the 4 out, it becomes a 2. So that's 2 root 13 there. And then I can go ahead and do some cancelling out. So the 2 and the 8 can cancel, and of course the 2 and the 2 cancel. So what I end up with is negative 4 plus minus root 13. And you can see I've got two solutions, the one where I add the root 13 and the one where I subtract the root 13. So that's how you would solve using the quadratic formula. All right, the next one, this one's going to use concepts of completing the square. So the first one says, well, the whole question says, let f, that's the function, that's the rule, so f of x equals 2x squared plus 12x plus 10. Write f of x in this particular form. So this is turning point form. Oops, turning point form, there we go. Now, of course, there's many steps that you can take to get there, but by the time you're in year 12, I do hope that you will be able to complete the square straight away. So I'm going to show you how I expect you to complete the square, and then I'll write in little writing as to the little steps in between. And you need to practice skipping those steps straight away. Now, the first thing that we will do, though, is because there is a number in the front, we will factorize that out. So there must never be anything in front of the x in order to be able to complete the square. So f of x will be equal to 2. I'm going to pull that out. That's x squared plus 6x plus 5. And now, this is a quick way to do it, right? We'll open a bracket. It's half of the middle term, which in this case is plus 3. We'll square that, and then you subtract the square of the half. So with the 6, there's a 3 there. That's the 3 squared. And then I'm going to subtract 3 squared, which is 9. And then plus 5. So I've actually done that in 2 steps. You can actually, what's even faster is to do that in your head to end up with minus 4. All right, so how is it that we actually got there? This is sort of now going to be the subtext part. What we do is we add half of the middle term and we subtract it. The reason for that is that I can't just randomly add a number, like that's changing the whole equation. But if I add and subtract it, I've actually done nothing. I've added 0 to it. All I've done is I've changed the form. Now the reason I've done that is because this part here is exactly what we spoke about earlier, a squared plus 2ab plus b squared, which when factorized gives us x plus 3 squared. So that's the reason that we complete the square, and this is the way that you skip the steps. So really I should have done it all the way here. So we want to be able to work to the point where we're able to do this in our head. Now of course this isn't the final form because we do need to factorize that 2 back in. Now if you can't get there straight away, don't worry about that. It takes a little bit of practice, but I'm just highlighting it because you don't want to be wasting your time writing this out and trying to factorize and doing all that. You need to be able to get there pretty much right away. All right, so that's part A. Part B then says, hence write down the coordinates of the turning point of the graph. So that's going to be H and K. And don't forget to change the sign for H. So that will be the turning point. All right, finally for this exercise, example 10, sketch this particular graph, state its domain and range. So here's the graph, and they've also given us a restriction for the domain. So for this graph over here, what I can tell is the turning point. What I'm going to do is I'm just going to write it in a slightly nicer form. The first thing is that you should never have anything in front of the x in order to be able to see the true translation. So what I'm going to do is I factorize anything I see, whether it's a negative or a number. I factorize that out. Notice that it's still bound within the square, so it's still in here, but I've just taken the 2 out, and that affects my translation. So what has actually happened is that the whole graph has moved over by a half, not by 1. So it's really important that you factorize that number out. And then there's a plus 9. So there's a few things that have happened here. The first thing I'm going to highlight is what the turning point is. So that's going to be negative a half and 9. So that's from our H and K, H and K. Now remembering back to that very first slide, what else do we need? We need the y-intercept and we need the x-intercept. So the y-intercept happens when x is equal to 0. So I'm going to go ahead and do that. I'm just going to use the first function though to do this because it means I get to avoid fractions. So 2 times 0 is just 0 plus 1 squared. 1 squared is 1. So our y-intercept is going to be 0 and 8. And finally, the last thing I need to be able to sketch it is the x-intercept. That happens when y is equal to 0. Again, I'm just going to use the original form rather than having to deal with fractions. I'm going to take this over so that I don't deal with negatives. So those are the two things I don't like, negatives and fractions. I'm going to take this square over by square rooting. And when I square it, the square root of 9 is plus minus 3. I'm then going to take the 1 over, so that'll be negative 1 plus minus 3, and then I'm going to divide everything by 2. So when I work that out, that's going to be negative 1 plus 3, which is going to be positive 2 divided by 2. That'll be 1. Then I'll have negative 1 minus 3, which is negative 4, divided by 2, which will be negative 2. So my two x-intercepts are 1, 0, and negative 2, 0. Now, generally, that would be all that I need. However, because I have a restriction of a domain, I actually also need to find the endpoints. So that's one extra thing we need to find for this graph in order to be able to sketch it. So I need to figure out what is the value when x is equal to negative 2 and what's the value when x is equal to positive 2. So when x equals negative 2, I get y equals 2 times negative 2 plus 1 squared. I mixed up the brackets, didn't I? 2 times negative 2 is negative 4, plus 1 is going to be negative 3, but the negative 3 squared is going to be 9. So that is going to be 0, and that actually makes sense. I probably didn't need to find that. That was a bit silly. I've already found the x-intercept there, but it's a nice way to be able to confirm that that's it. Then I'm going to do it for x equals 2. So that'll be y equals 9 minus 2 times 2 plus 1, all squared. 2 times 2 is 4, plus 1 is 5. 5 squared is 25, so I end up with 9 minus 25, which will be negative 16. So when x is 2, y is negative 16. All right, I'm going to go ahead now and sketch that in the little space that I have. I might quickly resize this. All right, so we're going to go and draw in some nice axes, label them as well. And let's put in all the information that we know. So the first thing I know, my turning point happens at negative a half and 9. Let's put that there. Might use a different color to separate it from the working out. Okay. Next thing I know is that my y-intercept is at 0 and 8. I also know that I have an x-intercept at negative 2 and at 1. The reason I stopped just then is because if you notice, the domain is actually not included on the turning point, so I'm going to have an open circle there. But my other x-intercept, which is at positive 1, will be a closed circle because that's a part of it. I've already done this endpoint. The other endpoint happens at 2 and negative 16. So that will be about there. Again, open circle. All right, I've mapped it out. I'm going to go ahead and draw the quadratic through as nicely as I can. Sometimes it's actually easier to just draw it and then put in your points, as you saw. That end point looked like it was a little bit out of the way. So I just redrew it. All right, let's put in all the points that we know. Okay, and there is your beautifully drawn quadratic. That's it for exercise 2A, or 4A.